Hey, hello and welcome. Today we are going to revise waves on strings with the help of previous year questions. तो वेव्स वाले चैप्टर में बहुत सारे फॉर्मूलेज हैं. मैं उन फॉर्मूलेज के बारे में ब्रीफली आपको बताऊंगा और थोड़ा सा डिस्कशन हम करेंगे बेस्ड ऑन सम कंसेप्ट्स और प्रीवियस ईयर क्वेश्चंस को लेकर के हम पूरे चैप्टर को रिवाइज करने की कोशिश करेंगे. So first of all, let's talk about waves. In waves, particle of the medium oscillate about their mean position, allowing the disturbance to travel from one point in a medium to another. तो बेसिकली वेव एक डिस्टर्बेंस है जिसकी मदद से एक जगह से दूसरी जगह एनर्जी ट्रांसमिट होती है. अब एनर्जी ट्रांसमिट करने के लिए पार्टिकल एक जगह से उठ करके दूसरी जगह नहीं जाते. पार्टिकल अपनी अपनी जगह पर ऑसिलेट करते रहते हैं और ओवरऑल डिस्टर्बेंस प्रोपोगेट होता है एक जगह से दूसरी जगह और इसी की मदद से एनर्जी ट्रांसपोर्ट होती है. अब अलग अलग टाइप की वेव्स होती हैं. कुछ वेव्स में तो मीडियम नहीं भी होता. ऐसी जो वेव्स होती हैं इनको बोलते हैं कि दे आर नॉन मैकेनिकल वेव्स. एग्जाम्पल इज लाइट. वो इलेक्ट्रोमैग्नेटिक वेव्स नॉन मैकेनिकल वेव्स की कैटेगरी में आती है जिसमें मीडियम की रिक्वायरमेंट नहीं होती. अच्छा, उसके अंदर पार्टिकल्स भी नहीं होते जो कि ऑसिलेट कर रहे हैं. उसमें हम ये बोलेंगे कि देयर आर इलेक्ट्रिक एंड मैग्नेटिक फील्ड्स जो कि ऑसिलेट कर रही हैं. इन दिस केस वी हैव पार्टिकल्स जो कि ऑसिलेट कर रहे हैं टू एंड फ्रो अपनी मीन पोजीशन के अबाउट. और ये एग्जांपल है मैकेनिकल वेव का जिसमें मीडियम रिक्वायर्ड होता है. और इसके अलावा जो साउंड वेव्स हैं दे आर ऑल्सो मैकेनिकल वेव्स, उसमें भी मीडियम रिक्वायर्ड होता है. तो जब मैं यहाँ से बोल रहा हूँ तो बेसिकली माइक्रोफोन तक आवाज़ पहुँच रही है. इसका ये मतलब नहीं है कि मेरे मुंह से हवा के मॉलिक्यूल्स हैं वो निकल के माइक्रोफोन के अंदर घुस रहे हैं. ऐसा नहीं हो रहा. So the molecules are vibrating and this vibration is transmitted to the neighboring molecules और फिर वो भी वाइब्रेट कर रहे हैं और उसके बाद में फिर और molecules वाइब्रेट कर रहे हैं and this is how the wave is propagating. And so this is the case. Now let me see the comments. So we have Nidhi and Bishu and S Giri and we have Bishu. Can you please teach in English for me? Okay, I'll teach in English, but you have to and not only for you but also for us. Okay, so I'll speak in English now and you have to keep on responding in the chat in English also. Okay, and these smileys are very very good. So basically we are talking about waves and there are different kinds of waves. We have mechanical waves and non-mechanical waves. We have talked about them. Basically wave is a disturbance and we can transmit energy from one point to another using this disturbance. Okay, fine. So now we have transverse waves and the particles of the medium vibrate in the direction perpendicular to the direction of propagation of wave. So these types of waves are known as transverse waves. Okay, you can see the black particle. When the wave is propagating, the black particle is vibrating perpendicular to the direction of propagation of wave. So this is an example of transverse wave. The waves on guitar string, they are also transverse waves. And we have another kind of wave which is known as longitudinal wave. Over here what happens? The particles of the medium vibrate in the direction of propagation of wave. Okay, so you can see when the disturbance is propagating, the black spot or the black particle, that particle is vibrating along the direction of the wave. Or let me say that in the direction of propagation of wave, we draw a line. Let me draw the line. Okay, this is the line in the direction of propagation of wave. Now along this line the particle will vibrate. So particle can have velocity in the direction of propagation of the wave and it can also have velocity in the opposite direction of propagation of wave. Okay, so this particle can vibrate to and fro. Okay, so the velocity of the particle and velocity of wave, they are two different things. We will talk about the relationship between them soon. So these are some of the important formulas which we have to remember. And first formula gives us the general equation of wave. So y is equals to a sine of omega times t minus x by v plus phi. and this can also be written as a sine of omega t minus kx plus phi. Omega is equals to 2 pi by time period, okay, and frequency is 1 upon time period, so omega is 2 pi f. This is angular frequency omega. So the equation is y is equals to a sine omega t minus kx plus phi, and here omega is the angular frequency, k is the wave number. So k is the wave number, k is 2 pi by lambda. Lambda is the wavelength. And we have the equation that velocity of the wave, this is equal to frequency times wavelength lambda. Now this frequency can be written as omega by 2 pi, and wavelength lambda can be written as 2 pi by k. So 2 pi by k, 2 pi by k, and this product is giving us the velocity. 2 pi cancels out 2 pi, and v is equals to omega divided by k. So this is the velocity, and we can remember the formula that omega is equals to kv. So I remember this formula, omega is equals to kv. Kv is also some school's name. So omega is that school's name, kv. So now motion parameters of particle. So if you know what is y as a function of time, you can also calculate the velocity. Just differentiate y with respect to time, you will get velocity, and then once again differentiate velocity with respect to time, you will get acceleration. And you can see over here the particles, they vibrate in simple harmonic motion. So this is the equation of harmonic wave. Y is equals to a sine of omega times t minus x by v plus phi. This is the equation of harmonic wave, simple harmonic wave. And the velocity of transverse wave, velocity of any transverse wave on a string is under root of t by mu. So t is the tension, mu is linear mass density. This is mass per unit length. So mu is mass per unit length. And over here you can see it is under root of some elastic property divided by some inertial property. Okay, so this is the general thing. This applies for the waves not only on a string, but this applies for sound waves also. So the velocity of sound wave would be of this type, whole under root of elastic property divided by inertial property. Now in case of sound, what is that elastic property, what is that inertial property? We will come to that when we study sound waves. Okay, fine. And now there is a question, why are we always representing wave in terms of sine even though cosine is also sinusoidal? So you are asking, why do we always take this sine? We can also take cosine. Yes, you can take cosine, no problem with that. If in case phi happens to be pi, then you can write y is equals to a sine omega t minus kx plus pi as y is equals to a cos of omega t minus kx. Okay, not pi but pi by 2. So if phi is equals to pi by 2, then you can say y is equals to a sine omega t minus kx plus pi by 2. Okay, and then you can turn that thing into cosine by applying some trigonometric rules. So anything is fine. Okay, good. And now over here we have a representation of wave. So what is the equation of wave? Write equation of wave. Write equation of this wave. Write equation of this wave. Now I'll give you some hints or some options. One of them will be true. One option is y is equals to a sine of omega t minus kx plus 0. Second option is y is equals to a sine of omega t minus kx plus pi. So which of these options represents the correct equation for this wave? This is a wave which is propagating in the horizontal direction, positive x direction, and you can see that the particles, they will vibrate in the direction perpendicular to the motion of wave. So which of these equations, A or B, represents the correct equation for this wave? यहाँ पर कौन सी वाली इक्वेशन सही है? What do you think? A और B? Which equation is correct? इक्वेशन A सही है या इक्वेशन B सही है? What do you think? इक्वेशन A सही है या इक्वेशन B सही है? Which equation is the right equation? Any idea? Which one is the right equation? कौन सी वाली इक्वेशन सही है? Which is the right equation? So you are saying equation B is right. You think? Bishu is saying. Okay, so let me ask you another question. The particle at origin, in which direction will it move? If the wave propagates in the positive x direction, in which direction this particle at the origin will move? You can say that the wave will go like that. The wave will go like this. Okay, so particle at origin, has it moved up or down? Up or down? ओरिजिन पर जो पार्टिकल है वो ऊपर गया है या नीचे गया है? दिस पार्टिकल एट ओरिजिन, हैज इट मूव्ड अप और डाउन? इन विच डायरेक्शन आर पार्टिकल हैज मूव्ड, अप और डाउन? You can answer this question. The particle has moved up or down. The yellow particle which was at origin, as the wave propagates, it will move up or down. ऊपर जाएगा या नीचे जाएगा? What do you think now? Up or down? Okay. Now I have drawn this wave like this. Okay. Just after time delta t, this is how the disturbance will look. Because the disturbance is propagated in the horizontal direction. So this is how our disturbance will look like. Okay. Now what is the disturbance? What is the disturbance on the y-axis? You will say the disturbance is like this and it looks like the particle has moved up. Is this clear? The particle which was at origin, this particle has moved up. So the particle has moved up. Okay, fine. So particle was at the origin and it has moved up. Is this clear up to this point? If this is clear, you can just paste some thumbs up in the chat so that I can understand this much portion is clear. The particle will move up definitely. Is this clear? Pakka? Definitely? Fine? Okay. तो ये particle ऊपर shift होगा. Now let us look at the motion of this particle. So the particle was at origin, it will move up, and then this maxima will, or you can say the mountain will arrive at the y-axis, and the particle will be at its highest displacement. Okay, after some time. After that, what will happen? This point will arrive at the origin, and the particle will move back to origin, and then what will happen? The valley or the trough will arrive, and then the particle will move down. Okay, then it will come back to the origin, then move up like that. So to and fro motion is happening where the particle is present. So now the motion of the particle is simple harmonic motion. Now let us write the equation of simple harmonic motion. So the equation of simple harmonic motion is y is equals to a sine of omega t plus phi. Okay, this is the equation of SHM. This is equation of SHM at x equal to 0. This is the equation of SHM, right? Now what is the value of phi over here? What is the value of phi? In this equation of wave, the general equation of wave is y is equals to a sine of omega t minus kx plus phi, right? So at x equal to 0, the equation is y is equals to a sine of omega t plus phi. This is the equation of SHM. Now in this simple harmonic motion, where the particle was at origin and then it will move in the positive direction, come back to origin, then move in the negative direction. For this simple harmonic motion, what is the value of phi? What is the value of phi now? Is it 0 or is it pi? What is the value of phi? Is it 0 or is it pi? What do you think now? Is it 0 or is it pi? What is the value of phi for this simple harmonic motion at origin? The particle moves in the positive direction. First, it moves to the greatest distance from the origin, and then it will come back to the origin. Okay, so this is the simple harmonic motion which is happening. So what value should we take? Should we take 0 or pi? Should we take 0 or pi? You know simple harmonic motion, right? Simple harmonic motion. Let me go to another slide. Let me just talk about simple harmonic motion. Suppose over here we have a mass. Okay, this mass is moving in the positive direction. Okay, it is moving to the greatest amplitude and then coming back, and then it will move in the negative direction. And you are writing y is equals to a sine of omega t plus phi. Now what should be the value of phi so that you get y as positive just after some time? You will say definitely it is 0. Because if y is a sine omega t, at t equal to 0, the y coordinate is 0. And then as we increase time, then y will become positive. Okay? If we increase time further, then y will become greater and greater and greater, and at some point y will become equal to a. So after that the y will decrease and become 0, and then y will become negative. So definitely we should write phi as 0. Is this clear to all? Is this clear to all? Over here the value of phi will be 0. Is this fine? For simple harmonic motion, if the particle moves in the positive direction, the initial phase constant, or you can say the phase constant, that is 0 if the particle moves from the mean position in the positive direction. Fine? Clear? You can write thumbs up, or you can give some smiley in the chat so that I get to know this point is clear. If basics are not clear, how can we study complex things? So is this fine? Okay? Clear to everyone? Perfect. If there is any doubt, you can ask. Right now, this is the best time to ask any doubt if there are any. Is this clear? क्या ये समझ में आ गया सब लोगों को, या सर के ऊपर से चला गया? अच्छा चलिए मैं एक और एग्जांपल देता हूं. अगर समझ में नहीं आया तो एक और एग्जांपल देता हूं. मान लीजिए एक पार्टिकल है, ये मीन पोजीशन पर रखा है. अब ये एक्स एक्सिस के अंदर ऑसिलेट कर रहा है. ठीक है, ये जाएगा पॉजिटिव एक्स डायरेक्शन में, फिर मैक्सिमम एम्पलीट्यूड ए पर जाएगा और फिर वापस पीछे आ जाएगा, फिर नेगेटिव डायरेक्शन में जाएगा और फिर वापस मीन पोजीशन पे आ जाएगा. ऐसे तो ये ऐसे एसएचएम कर रहा है. अब इसकी अगर मैं इक्वेशन लिखना चाहूंगा तो मैं लिखूंगा x इज इक्वल टू ए साइन ऑफ ओमेगा टी, राइट, क्योंकि ये पॉजिटिव डायरेक्शन में जा रहा था, है ना. ये नेगेटिव डायरेक्शन में अगर जाता तब हम इक्वेशन लिखते a sin ओमेगा t प्लस पाई, ये तब लिखते जब पार्टिकल नेगेटिव डायरेक्शन में जा रहा होता है इनिशियली, मगर ये तो पॉजिटिव डायरेक्शन में जा रहा था, इसलिए हमने ये लिखा x इज इक्वल टू a sin ओमेगा t प्लस 0, क्योंकि इनिशियली ये पॉजिटिव साइड जा रहा था, राइट? ओके फाइन। तो इसी तरीके से यहां पर भी हमारा जो पार्टिकल है, ये जो येलो कलर का पार्टिकल है ओरिजिन पर, ये पॉजिटिव y डायरेक्शन में जा रहा है, इसलिए हम लिखेंगे y इज इक्वल टू a sin ओमेगा t प्लस 0। अच्छा, इसका मतलब फाई की वैल्यू 0 हुई। और अगर आपको वेव की इक्वेशन चुननी है तो आप चुनेंगे y इज इक्वल टू a sin ओमेगा t माइनस के एक्स प्लस 0। जब आप x इक्वल टू 0 पुट करेंगे तो आपके पास इक्वेशन आएगी y इज इक्वल टू a sin ओमेगा t, SHM की इक्वेशन आएगी। ओके, सो a इज राइट, यहां पर a सही है और b गलत है। इज दिस क्लियर? फाइन। अब क्या समझ में आ गया सब लोगों को? इफ देर आर एनी डाउट्स यू कैन आस्क इन द चैट। इज दिस ओके? नाउ let me write another way to write this equation, another way to write this equation, another way to write equation, that is like this: y is equals to a, now we can say a sine of kx minus omega t plus pi. Okay, so what we have done, omega t minus kx plus 0 was present. Now we are writing this we are writing this as kx minus omega t plus pi. So this will give us back our equation y is equals to a sin omega t minus kx plus 0. Okay, so both of these equations are same mathematically, so you can choose whatever equation you like. Now similar kind of question was asked in JEE 2019. I would suggest you all to go over this question on your own, okay, without any external help. If you try this question on your own, then you will learn. So I have given you the way to tackle all these questions. Now let me go to some other important formulas. Over here we have relation between wave velocity and particle velocity. So particle, our particle, let's take our particle to be P1 and P2. So let's talk about this particle P2. Now this particle is moving in the negative direction at this point, because the wave is propagating in the positive direction. So after some time the wave will look like this, the disturbance would look like this. So the particle has to move down, so the velocity of the particle was in the downward direction. Now this velocity of the particle has some relationship with the velocity of the wave v. So vp is the particle velocity, this is negative of wave velocity v times the slope. The slope over here is del y by del x, or dy by dx you can say, that is the slope. So vp is equals to minus v dy by dx in this case. Okay, so velocity of the particle is equals to negative of v times slope of y-x curve, y versus x curve, slope you can find out. And the equation of wave has the formula del square y by del t square, this is equal to v square times del square y by del x square. Over here this del square y by del t square, this is the acceleration of the particle, and we have v square, this is the velocity of wave square, and then we have del square y by del x square, this is the rate of change of slope. This is the rate of change of slope in this y versus x curve, or you can say the wave curve. Now we can move on. Relationship between phase difference and path difference. phase difference and path difference relation we will see. That relation is very, very important. Always remember this relation. This is delta phi. The phase difference, this is equal to 2 pi by lambda times delta x. Okay. Now let me explain this. Now the equation of wave is y is equals to a sine of omega t minus kx plus phi. This is the equation of this wave, which we can see in the figure. Now if I ask you, at location x1, what is the value of y? You will say y1 is equals to a sine omega t minus k x1 plus phi. For different time, we will get different values of y. So this is y at location x1. Now if I ask you what is displacement at location x2, you will say y2 is equals to a sine omega t minus k x2 plus phi. So this is y2. At different time, at this location at this location x2, we will have different displacements of the particle. Now definitely the phase angle for y1 and phase angle for y2, they are different. The difference in the phase between the particles is given by this phase angle for y1 minus phase angle for y2. So omega t minus kx1 plus phi minus omega t minus kx2 plus phi. If you take the difference, you will get delta phi as k times x2 minus x1. This is k times delta x. So delta phi is k times delta x, and k is 2 pi by lambda. So delta phi is 2 pi by lambda times delta x. This is the equation to remember. Fine? Okay. Now let us look at this awesome question. It is from advance, and the question says a transverse sinusoidal wave moves along a string in the positive x direction at the speed of 10 centimeter per second. So this wave is moving in this positive x direction with the speed of 10 centimeter per second. Now I will ask you, first of all, what is the equation of wave? I will give you some of the options. Okay. So my first option is, equation of this wave is y is equals to a sine of omega t minus kx. Let me write it over here. The equation of this wave is first y is equals to a sine of omega t minus kx plus 0, or second is y is equals to a sine of omega t minus kx plus pi. I will read the question, complete question, but first of all, you must know how to write the equation just by looking at the photo. So which of these equation is the right equation, first one or the second one? First equation, y is equals to a sine omega t minus kx plus 0, or y is equals to a sine omega t minus kx plus pi. Which is the correct equation for this photo? This over here, we have a wave which is propagating in the x direction. So which is the equation? So Bhishu is saying second one. Don't write maybe. Certainly you should say second one. Certainly. Like that, definitely second one, obviously second one, like that you should say. Okay, so now let me just explain that. Second one is the right equation. You are correct. Now what will happen? The particle was at origin. Now as the wave propagates in the x direction, the disturbance will look like this. Okay. And you can see the particle has to move down over here. The particle will move in the downward direction. So we can say that this particle is performing simple harmonic motion. So at x equal to 0, y is equals to a sine of omega t plus phi, right? and as the particle is moving in the negative direction, we can say phi over here will be equal to pi. The particle is at origin and moving in the negative direction, so phi will be equal to pi. And this result we get only from the second one, not from the first one. So second one is the correct equation. Perfect. So we know how to write the equation of this wave. Now we are eligible to read the question. Okay, then we might be able to solve the question. Yes. So Bishu is now saying second one, obviously. Okay. So now let me read the question complete. Transverse sinusoidal wave moves along a string in the positive x direction at the speed of 10 centimeter per second. The wavelength of the wave is 0.5 meter and its amplitude is 10 centimeter. So the amplitude of the wave is 10 centimeter. A is equals to 0.1 meter and the wavelength of the wave is 0.5 meter, lambda is 0.5 meter and its amplitude is 10 centimeter. So 0.1 meter is the amplitude and the speed of the wave is 10 centimeter per second. So V is equals to 0.1 meter per second. At particular time, the snapshot of the wave is shown in the figure. The velocity of point P when its displacement is 5 centimeter is. So the displacement of point P from its mean position is 5 centimeter. This is 5 centimeter. So Y at the location P or Y for point P, this is 5 centimeter. Now we have to tell what is the velocity of point P. What is VP? What is the velocity of point P? We have to tell this. Now we have some answers from Divya and Pratham. They are saying option A is the answer. Okay, so I will give some time for you to solve the question, and I think the answers Divya and Pratham they are giving, and it might be the correct one. And Ayush is saying, please take rest. Who? Please take rest. I'm taking rest if you are asking for that. Okay. So this is the best rest for me. One of the best rest for me. So now, what we can do, over here we know the velocity of particle is asked, and velocity of particle, this is equal to velocity of minus velocity of the wave times slope. Now what is the slope over here? Slope is del y by del x. Okay, so we have slope. So this is one of the formula to calculate the velocity of particle. Otherwise, the other formula is like this. Just differentiate this y with respect to time, you will get velocity of particle. This is a omega sine of omega t minus kx plus pi. So this is the velocity of particle. So we can use either of the formulas. If you want to use the first formula, use it. Second formula, you can use that. So what I'll do, I'll use the second one. Okay. So now, we have some informations about point P. The information about point P is this. At t equal to 0, this is the snapshot, right? So at t equal to 0, the value of y for point P, that is equal to 5. So we can say 5 centimeter or 5 by 100 meter, or I can write 0.05 meter. This is equal to amplitude A, which is 10 centimeter or 0.1 meter, times sine of omega t minus kx plus pi. Okay, this is at t equal to 0. At t equal to 0, this is the equation. We can put t equal to 0 over here also. Omega t will become 0. But don't worry about that. So we can say that we are getting sine of omega t minus kx plus pi. This is coming out to be equal to half. Okay, this means omega t minus kx plus pi is 30 degree. So we can say we are getting omega t from this equation, we are getting omega t minus kx plus pi, this is 30 degree. This is equal to 30 degree. We are getting it from this equation. Now, velocity of the particle, this is equal to a omega. I had to differentiate that, right? So y was a sine omega t minus kx plus pi. Now differentiation of that will be Vp is equals to a omega cos of omega t minus kx plus pi. Not sine but cos. Differentiation of sine is cos, right? And then differentiation of cos is minus sine. So by mistake I have written sine, but now I have corrected the mistake. It is cos. Okay. So now velocity of particle Vp, this is equal to a omega. Then we have cos of omega t minus kx plus pi, and this is equal to 30 degree. This is equal to 30 degree. We have to find the velocity of particle at t equal to 0. At t equal to 0, omega t minus kx plus pi was 30 degree. So now we just have to put the value of omega, and omega is equals to kb. We know the formula of omega. Omega is equals to kb. So Vp, this is equal to a kv cos of 30 degree. Okay, now let's put all the values. So amplitude is 10 centimeter or 0.1 meter, and then k is 2 pi by lambda. Lambda is given to be 0.5 meter, and then we have velocity of the wave. This is 10 centimeter per second, or we can write 0.1 meter per second. This is the velocity of the particle. V is equals to 0.1 meter per second, right? 10 centimeter per second is 0.1 meter per second, and then we have cos 30 degree, that is root 3 by 2. So from this you will get the answer. So what are we getting? This 2 will get cancelled out, and we are getting root 3 pi divided by 50. So this is the velocity of the particle. Now tell me point P, is it moving in the upward direction or downward direction? The velocity of point P is in the upward direction or downward direction? Up or down? What do you think? The velocity of the particle is up or down? Particle ऊपर जा रहा है या नीचे आ रहा है? कहाँ जा रहा है particle? Where is the particle moving? Up or down? At this instant, in which direction the particle is moving, up or down? Up or down? See, I'll draw how the disturbance will look like after some time. So the disturbance is propagating in the x direction. So this is how the disturbance will look like after some time. Okay, so now you can see the particle has moved in the upward direction. Yes, perfect. So upward direction, the particle has moved in the upward direction, up, not downward direction, upward direction obviously. See, the particle was moving in the upward direction, okay? And after that, what will happen? After some time, the crest will arrive at this location, and the particle would have moved to the highest point, okay? Particle highest point पर पहुंच जाएगा थोड़े time बाद, okay? So Pratham is saying the velocity will be in plus j cap. Okay, so Vp vector, if you want to write, you have to put j cap over here, unit vector j cap. So this will give you Vp vector. Okay, now let us see the options. We can see option A is the right answer for our question. Is this clear? Done? Everybody understood? Right? Okay. अच्छा, किन किन लोगों ने किसी अलग मेथड से सॉल्व करा था? जो मेथड मैंने अभी सॉल्व करा, इसके अलावा किसी और ने कोई दूसरा मेथड यूज करा हो? हैव यू यूज्ड अनदर मेथड टू सॉल्व दिस? किस किस ने दूसरे मेथड से सॉल्व करा? यू कैन कमेंट इन द चैट. नाउ what we will do now, we will revise some of the formulas and then we will move to next question. Next subtopic is interference of waves. So let's suppose we have two waves going in the same direction. Now each of the wave individually have the potential to vibrate the particle. Okay, so we can say that each wave individually have the capacity to vibrate the particle. So this is wave 1. Equation of wave 1 is y1 is equals to a sin omega t minus kx, and we have the other equation y2 is equals to a2 sin omega t minus kx plus delta. Yes, okay. And now these two waves we will superimpose them to get another wave. So let me look at the chat. So yes, Pratham has solved this question, the previous question with a different approach. Vp is equal to omega square root of a2 y2 from SHM. Okay, so Pratham has solved this question using this. He has said that velocity of the particle would be equal to omega times under root of a square minus x square. So he has used this approach, and good. Yes, ये भी अच्छा अप्रोच है और यहाँ से भी आप सीधा सीधा निकाल सकते हैं. Now over here we have two waves. दोनों की इक्वेशन गिवन है. y1 is equals to a1 sin omega t minus kx and y2 is equals to a2 sin omega t minus kx plus delta. Now these two waves will superimpose with each other, and I think they have written they have drawn the graphs not perfectly. If they want to write this equation, then you know how the graphs looks like. This is how the graph should look like for this equation, right? Sometimes people make mistake in drawing graph. Okay, so this won't be the correct graph. The correct graph would be this white one. Okay, now you can understand that. But anyhow, there are two waves. We have two equations, one and second. We are not concerned with the looks of these equations, but they are these waves are superimposing with each other to give us the final wave. Now the final wave can be written in this form. The final wave equation can be written in this form. Y is equals to net amplitude A times sine of omega t minus kx plus some constant, and we will write it as phi. Okay, so now the net amplitude A can be written as whole under root of a1 square plus a2 square plus twice of a1 a2 cos of delta. Okay, like this. And you can find out this phi also. Phi is tan inverse of let me draw a phasor diagram for you so that you can visualize what we are doing. So what we are doing, we are saying that let's take any position, let's say x equal to 0, and let's look at what is happening at that position. So you will say at that position SHM is happening. So y1 is equals to a1 sin omega t. Y1 is equals to a1 sine of omega t. This is at x equal to 0, and y2 is equals to a2 sine of omega t plus delta. This is happening at x equal to 0. Now there are two disturbances at this particular location. So the resultant will be a simple harmonic motion, and for that simple harmonic motion we can draw phasor diagrams individually and add them. So for the first phasor, we draw an arrow of length a1. For the second one, we draw an arrow of length a2 with an angle delta over here. Okay, and then we have the superimposition, we have the addition of them. So this is the net arrow of value a, and this angle is, let's say, phi. Okay, let me not write phi, I will write this as alpha. Okay, I will write this as alpha. So this angle is alpha. Okay, now if I ask you what is a, then you can directly give from the vector addition that a is whole under root of a1 square plus a2 square plus twice of a1 a2 cos of delta. And if I ask you what is tan of alpha, then you will say this is a2 sine of delta divided by a1 plus a2 cos of delta, right? This is how you will tell what is tan of alpha. And if I ask what is alpha, alpha is tan inverse of this thing. So this is how we see the things. And the final equation is y is equals to a sine omega t minus kx plus alpha. You know what is alpha, you know what is a. So you get the final equation of the superimposition of waves. If the two waves are moving in the same direction with the same frequency, then you know how to superimpose these waves. Okay, now let me read the comments. If there are any doubts, I will address them. So Rehan has written something. When a wave hits the surface, does its amplitude change? जब वेव सरफेस को हिट करती है तब क्या उसका एम्पलीट्यूड चेंज होता है? Well, the amplitude we see changes when the wave of ocean comes near the surface. ऐसा हमको दिखता भी है. And Pratham is saying, no, the amplitude does not change. There may be change in the phase difference of the wave, but its amplitude will be constant. Well, ये तो एक observational चीज़ है कि आप देख सकते हैं कि जो सी के किनारे जो वेव्स आती हैं, जैसे जैसे वो शोर की तरफ आती हैं तब डेप्थ चेंज हो जाती है, और जो एम्पलीट्यूड होता है वेव का वो भी हमको चेंज होता हुआ दिखाई देता है. उसके पीछे क्या रीज़न होता है वो एक अलग बात है, तो उसकी हम अभी बात नहीं कर रहे कि व्हाट इज़ द रीज़न बिहाइंड दैट, बट दैट इज़ अ क्यूरियस थिंग टू पॉन्डर ऑन. नाउ इंटरफेरेंस ऑफ वेव हमने देखा. हमारे पास में जो फाइनल वेव की इक्वेशन है दैट इज y इज इक्वल टू a sin ओमेगा t माइनस kx प्लस अल्फा. सो वी मस्ट नो हाउ टू कैलकुलेट a. सो दिस इज हाउ वी फाइंड a एंड दिस इज हाउ वी फाइंड tan ऑफ अल्फा, एंड y इज इक्वल टू y1 प्लस y2. तो हमने क्या करा, बस इन दोनों को ऐड कर दिया. सो y इज इक्वल टू a1 साइन ऑफ, और लेट मी राइट y इज इक्वल टू y2 plus y1. So y is equals to a2 sine of omega t minus kx plus delta plus a1 sine of omega t minus kx. इन दोनों को आपको ऐड करना है. ये साइन वाली चीज़ों को ऐड करेंगे तो ट्रिग्नोमेट्री लगेगी यहाँ पर, और फाइनली आपके पास में ये रिजल्ट आ जाएगा, a आ जाएगा और ये tan ऑफ अल्फा आ जाएगा. इसके अलावा maximum amplitude that is equal to a1 plus a2. This is for constructive interference. Okay, when cos of delta is 1, we get the maximum amplitude a1 plus a2, and minimum amplitude is a1 minus a2. This is in the case of destructive interference when cos delta is minus 1. तो maximum amplitude के केस में जो phase difference है वो multiple of 2 pi होता है. So this is a1 a2. जब मल्टीपल ऑफ 2 पाई होगा तो कंस्ट्रक्टिव इंटरफेरेंस होगा. डिस्ट्रक्टिव इंटरफेरेंस में मल्टीपल ऑफ ऑड मल्टीपल ऑफ पाई होता है, तो या तो वो पाई हो या 3 पाई हो या 5 पाई हो एंड सो ऑन. सो दिस इज a1, दिस इज a2. ये हमने फेजर बनाए और इस तरीके के फेजर होते हैं फॉर डिस्ट्रक्टिव इंटरफेरेंस. ओके, इज दिस क्लियर? यस, फाइन. ओके, नाउ वी हैव दिस क्वेश्चन ऑन इंटरफेरेंस ऑफ वेव्स. सो व्हेन two progressive waves, y1 is equals to 4 sine of 2x minus 6t and y2 is equals to 3 sine of 2x minus 6t minus pi by 2 are superimposed, the amplitude of resultant wave is. So what is the amplitude of resultant wave? What is the amplitude of resultant wave? You have to find what is A. Now let me give you 30 seconds to give the answer. The time starts now. 30 सेकेंड है आप लोगों के पास में. You can give the answer and 30 सेकेंड है. So Pratham is saying 5. Sai Kiran has also come. And somebody was asking in the chat, will you take session tomorrow? Tomorrow I won't take the session. Tomorrow is Saturday, I believe. Tomorrow you can see shorts, a YouTube short of some interesting experiments if you want to see. And the next session will be on Monday. Maybe on Monday or Tuesday. We will see. Okay. And it will be posted in the channel. And basically we are having about 4 sessions in a week. So 2/11th, 2/12th, you can come and join whenever you like. So Sai Kiran and Pratham both are saying 5, I think. And Sai Kiran has posted 5 times. So A is whole under root of 4 square plus 3 square plus twice of 4 times 3 times cos of phase difference between them is pi by 2. And from this you will get A is equals to under root of 4 square plus 3 square. A is equal to 5. Very simple question. Yes, this is advanced. Yes. It was subjective question from JEE 2010, I think. So, sometimes easy questions also come, but we should be prepared for difficult one also. So we have difficult questions in our session also. So stay tuned for them. So we have power transmitted. Average power is 2 pi square A square F square times mu times V. This is the average power. Okay, and it can also be written as half mu A square omega square V. So what is mu? Mu is mass per unit length. What is A? A is the amplitude, omega is the angular frequency, and V is the velocity. So this is how we should look at this formula. This is the easier version. Okay, and you can you can write the equation of energy for simple harmonic motion. Okay, and you have lots of simple harmonic motion over here. So you can figure out how much energy is in the length V of the wave. Okay, and that much energy will be transmitted in 1 second. So from that you can derive this formula of power transmitted. Power transmitted is energy transmitted in 1 second. In 1 second, V length of the wave will cross a particular portion. And what is the total energy in the V length of the wave? That you can find out if you know how to calculate the energy of simple harmonic motion. And we have lots of simple harmonic motion over here. So you can figure out the total energy. Now, intensity is average power divided by area. So if we are talking about the waves on a string, the area will be area of cross section of the string, which is pi r square. Okay, so just divide the average power by pi r square, you will get the intensity. The important thing over here is intensity is proportional to A square. This is the formula for intensity. Intensity is proportional to amplitude square. And now for superimposition, we got the formula, right? So you can get the formula for intensity also. So if you square both the sides, you will get this awesome thing. You will get A square is equals to A1 square plus A2 square plus twice of A1, A2 cos of delta. Now amplitude square is proportional to intensity. So we get intensity, final intensity after superimposition I. This is equal to I1 plus I2 plus twice of under root of I1 under root of I2 cos of delta. Okay, this is the formula for intensity. So this is also a handy formula to remember. And you know what will be the maximum intensity when cos delta is equal to 1, and what will be the minimum intensity when cos delta is -1. Okay, yes, fine. And okay, so now we have the question. Let me take this question. Okay, the question says two pulses in a stretched string whose centers are initially 8 centimeter apart are moving towards each other as shown in the figure. The speed of each pulse is 2 centimeter per second. After 2 seconds, the total energy of the pulses will be. So over here we have some initial energy of the system, right? Now that energy is in the form of potential energy as well as kinetic energy. How? See, let's suppose this is how the this is how the shape of the wave is. Now let me show you a particular portion, this portion, right? So when there was no wave over here, then this portion was horizontal like this. Now when the wave crosses this point, then first of all this portion has some velocity, and there is some kinetic energy associated with this portion, and also we can say that there is some stretch in this portion. This portion is stretched, okay, like this, stretched. So this portion is stretched. Now due to the stretching in this portion, there is some elastic potential energy. So basically there is kinetic energy as well as potential energy associated with this portion. And after some time, the potential energy in this portion will be 0 when there is no stretch, and that might be when the portion is like this. Okay, so when the crest will arrive, the portion will be horizontal, you can say. The wave would have moved like this. Okay, like this. Okay, so this crest, when it has arrived, then the portion will be perfectly horizontal. When it is horizontal, there is no stretching in this portion, so there is no potential energy over here. So you can see the energy may not always be in the form of potential energy. Sometimes potential energy also becomes 0, and this also happens for kinetic energy also. So when the particle is at its extreme position, then the kinetic energy becomes 0. So this portion has transmitted whatever energy it has to the neighboring portion, and the neighbor will also do the same. So that's how the energy will be transmitted from one location to another. So that was brief talk about energy. But now let's come back to our question. Our question says that we have two waves, two pulses propagating in the opposite direction, and they are initially 8 centimeter apart. Now after 2 seconds, the total energy of the pulses will be. So we have to talk about the total energy of the pulses, in which form it will be present. Option A, the total energy will be 0. Option B is saying it will be purely kinetic in nature. Option C is saying it will be purely potential in nature, and option D is saying it will be purely kinetic and potential. So what do you think? The total energy of the system, will it be purely kinetic in nature, purely potential in nature, purely kinetic and potential? What do you think? So Sai Kiran is saying purely kinetic. Okay, so let me show you what happens after 2 seconds. Okay, each pulse is going with 2 centimeter per second. Okay, so after 2 seconds, the first pulse would have traveled a distance of 2 centimeter per second times time 2 second. This is 4 centimeter. Okay, and the second pulse also would also have traveled 4 centimeter. So what would be what would be the shape? So over here we have the first pulse which has traveled 4 centimeter distance, and then we have the second pulse which has traveled 4 centimeter of distance. Okay, this has traveled 4 centimeter distance, and what will be the resultant over here? The resultant will be like this. So both will superimpose with each other. Okay, the displacements will add. So this height and this depth will add up and they will cancel each other out. So there is no displacement of any of the particle. The wave, the pulses are invisible for a while. Okay, but after that what will happen? After that, this yellow pulse would be over here, and the blue pulse would be over here. Okay, like this. Like this. So it will go in this direction and it will go in this direction. So this will happen after the pulses have crossed each other. But we are talking what happens at t equal to 2 seconds. This is at t equal to 2 seconds. So at t equal to 2 seconds, it appears that as if there are no pulses, but they are in some invisible form. They are not visible, but there is some energy over here. Now, as there is no stretching in the string, that energy cannot be in the form of potential energy. Elastic potential energy comes only when there is some distortion in the string. But over here we cannot see any distortion. Okay, no extension, no compression. So basically, whatever energy we have, that will be in the form of kinetic energy, and energy is conserved. So initial energy is equals to final energy. Energy is conserved. So there is energy first of all, but that is not in the form of potential energy. So it must be in the form of kinetic energy. And we can also see that when the particles are at mean position, then their velocity is maximum. So V is maximum. V particle is maximum. Velocity of particle is maximum. Velocity of particle is maximum. So the energy is in the form of kinetic energy. So option B is the right answer. Okay. So now Bishu is saying after 2 seconds, crest moves 4 centimeter towards right and trough means 4 centimeter towards left. They superimpose and cancel the displacement of each other. The string becomes straight. The energy becomes totally kinetic. Yes, totally right. Yes, every point is at mean position. Perfect. So you guys are perfectly correct. Now we will talk about reflection of a string wave from a fixed end, and we will solve some questions on that. So basically over here you can see that we have a pulse coming at a point which is attached to the wall. Now obviously the wall would not move up and down, so what will happen? The wave will reflect back. It will take back its energy. So now you can see at this place we have a fixed point. So this cannot move up and down. What happens? The wave reflects back and goes back. And you can see if the wave comes upright, it will be inverted when it goes back. So there is phase change of pi. Phase change of pi. Okay, this occurs, and you can visualize this thing in some cool fashion. Now look at this. This is one of the cool fashion to visualize this thing. You can imagine an imaginary pulse coming on the other side of the wall. Okay, and imagine that the original pulse, the blue pulse, this has crossed the wall, and the other fake pulse, this has entered the string. Okay, now we forgot the original pulse, and then we are talking about the second pulse, okay, the ghost pulse. That becomes the real pulse, and the first pulse, which was traveling towards the wall, the blue pulse, that becomes now the ghost pulse. Okay, so this is a cool fashion to visualize this, and this always gives us the right thing. You can see their displacements are cancelled out over here, so the displacement of the final thing is 0. Okay, this is the reflection from the fixed end. The amplitudes cancel each other out and the wave propagates like this. And now we have reflection from the free end. Okay, now let's look at this reflection. So from the fixed end, you have seen what is the thing. We have omega t minus kx. This is giving us the wave propagating in the positive x direction. This was the blue pulse, equation of blue pulse. Now after reflection, what happens? The wave propagates in the negative direction. So whatever sign we have in front of omega, we have the same sign in front of k. So if omega has positive sign in front of it, the k will also have the positive sign in front of that. So this represents the wave propagating in the negative direction. And also, I have written something earlier. There is a phase change of pi, which occurs when the wave hits the wall. So we also account this pi over here. This is the phase change when the wave encounters the wall. So this is the equation of the reflected pulse, or reflected wave, you can say, reflected wave. Okay, yes. And then we have reflection of a string wave from free end. Now for this, what you can do, you can see that the wave moves over like this, and then we have the free end. So free end moves up to a distance of 2a. If a was the amplitude of the wave, the free end moves up to 2a. Okay, look, this was the amplitude of the wave, but the amplitude was a, but now this end has risen to a height of 2a. Okay, look. So basically we can say the situation can be imagined in this fashion. There is another wave coming from the other direction of the wall, and what happens when both the waves overlap with each other, there is superimposition of them. If both the pulses are having amplitude a, then a plus a will become 2a. Okay, so this is kind of superimposition. So we can imagine blue pulse traveling, and then it goes into the wall, and another red pulse which was traveling, which was imaginary pulse, which we took in our imagination, which was traveling from the wall. That pulse overtook the thing, and it starts traveling in a negative direction beyond the wall. Okay, so this is how we can visualize the thing using our imagination. And the equation we can write a sine omega t minus kx for the blue pulse, and for reflected pulse we have a sine omega t plus kx. Okay, there is no phase change over here, so no phase change. This is not inverted. Okay, if the incident pulse is upright, the reflected pulse is also upright. Fine. Now we have standing waves. So over here we will discuss the concept briefly. So what is happening over here? We have two waves coming in the opposite direction to each other, and they are having the same angular frequency and same wavelength. So they are traveling in the opposite direction, and they will overlap with each other. So let us look at what the overlap looks like. So this is how the overlap will look like. You can see in the overlap or in the final superimposition, we will have each particle performing simple harmonic motion, but there are some particles which do not move at all. These particles are known as nodes, or these places are known as nodes. There are some particles which move to the maximum amplitude, so they are at the location of antinodes. So these are locations of antinodes. And the rest of the particles, they vibrate with an amplitude between node and antinode. So this is the final thing after superimposition in opposite direction of the waves in opposite direction. And you can see at some time the entire string becomes flat. Okay, but at that time there are some particles which are moving with the maximum velocity. Nodes are not moving at all, but all the other particles, whatever maximum velocity with which they can move, they are moving with that maximum velocity, and that is the thing. Now Sai Kiran is asking, reflected wave will have a minus. Please correct that. So where is the reflected wave? This reflected wave over here, y is equals to a sine omega t plus kx. Why? See, if the wave is traveling in the negative direction, so it will have whatever sign is in front of omega, that same sign should be in front of k. So in front of omega there is positive, so in front of k also there will be positive. So for reflected wave, it is a sine omega t plus kx. So are you saying that? Is this clear? If there is any doubt, you can ask in the chat. Sai, is this clear? Okay, so fine. Now let me take this position as x equal to 0. So what I'll do, I'll write what happens at x equal to 0. The equation of simple harmonic motion for the incident wave is a sine of omega t at x equal to 0, and for reflected wave it is a sine of omega t. So this is superimposition of two SHM. So when we add them up, we get 2a sine of omega t. And look, the amplitude was a over here, but it becomes 2a. Okay, see, the amplitude was a, then it becomes 2a. So this is 2a sine omega t, right? If there would have been minus over here, then we would have got 0, like that. I think if you want to write minus sign, then you should go for that case where the point was fixed to the wall. Over here, this is the free end. There is no wall. So we get negative sign only in the case when we have wall. Okay? Yes. At x equal to 0, total displacement must be 0. No, this is free end. Reflection of wave from a free end. Okay? So over here we have the displacement 2a. Right? And if you want the reflection of the string from a fixed end, then see. We have the first equation, a sine omega t minus kx. So at x equal to 0, what is the equation? A sine of omega t. This is at x equal to 0. And for the reflected wave, if we put x equal to 0, we get a sine of omega t plus pi, right? So if we add them up, we get a sine omega t minus a sine omega t, that will come out to be 0. So if there is a reflection of a wave from a fixed end, then the equation of the reflected wave is a sine omega t plus kx plus pi. So there is a phase change of pi. So this is the phase change of 180 degree. Okay, and then you can see the resultant is 0. Is this okay? Understood? All doubts resolved? Perfect. Shall we move ahead? Okay. So now we were talking about standing waves. So we saw that two waves come towards each other. They are having the same omega and same wavelength, and they are producing this awesome thing known as standing wave. Now you can see the blue and the red wave, they are moving in the opposite direction. And see, when they exactly overlap with each other, then we get everything at its peak amplitude. But when they cancel each other out, we get a straight line like this. So this is how we see the superimposition of waves traveling in opposite direction. And you can also produce this kind of pattern. What you have to do, you have to oscillate a string, and you are producing waves which are traveling towards the wall. And let's say the waves, they come at this fixed point at the wall. Now we had to imagine that there is kind of superimposition going on. So what we have imagined is that there is another wave like this moving in this direction, okay, and the boy is producing this wave moving in the forward direction. So these two waves superimpose with each other, and finally we get a standing wave over here. So you can see here is the node, here is also a node, and the interesting thing is, in between two nodes the separation is lambda by 2. And this is another node, his hand is also node. So in between his hand and this node, the separation is lambda by 2. Okay, so in between two consecutive nodes, the separation is lambda by 2. So this is what you have to remember. Now you can see we have drawn a standing wave over here. The net amplitude is 2, the final amplitude of the antinodes at the antinodes is 2a. The amplitudes at the other locations is different, but at antinodes it is 2a. This is the picture we have drawn at t equal to 0. Then at t equal to t by 4. So after 1/4 of the oscillation, we can see those particles which were at the extreme, they will come to the mean position. So all these particles were at their extremes. All of them have reached the mean position. Then after some more time, at t equal to t by 2, so when after 1/2 of the oscillation, all the particles which were at their positive extreme will move at the negative extreme, and all the particles which were at the negative extreme at t equal to 0, they would have moved to the positive extreme. So this is the thing at t equal to capital T by 2, and then after t by 4 time, after this we have t is equals to 3t by 4, and the particles will reach the mean position again. When the particles are at the mean position, they have produces waves. What happens? There is kind of energy loss which happens. So amplitudes, they won't keep on adding to till infinite amplitude, because there is kind of energy loss to the surrounding. So the amplitude does not reach infinity. Okay, so waves from the boy will travel to the wall, and the waves will reflect back, and they travel back to the boy, and then again after reflection from the hands of the boy, they will travel towards the wall, and then again reflect back and come back like that. So the net amplitude won't reach infinity, because there is some loss of energy to the surroundings. Now here are some useful formulas for the waves, for the standing waves. So if we have standing wave between two fixed ends, then we can say that we have n number of loops. One loop is in between two consecutive nodes, and you can see the separation between two consecutive nodes is lambda by 2. This is the separation between two consecutive nodes. Okay, this is also lambda by 2, and again and so on. So if we have n loops, so we have the total length L as n times length of each loop, and there are n loops, so n times lambda by 2. This is the total length L. and what we can say, lambda is equals to V divided by frequency f. So the total length is equals to NV by 2f, and you can say the frequency is equals to NV by L, NV by 2L. This is the frequency at which we can make standing waves. So for n equal to 1, we have fundamental frequency f naught. This is equal to V by 2L. And then for n equal to, this was for n equal to 1. And then for n equal to 2, we have 2V by 2L. Then we have 3V by 2L. Then we have 4V by 2L, and so on. So the frequencies which are permissible are f naught and 2f naught and 3f naught and 4f naught, and so on. So when standing waves are produced, these frequency will be seen in the string. So guitar strings are also like these strings. They are fixed. Their ends are fixed. So when we oscillate a particular or give energy to a particular string, there are many frequencies of standing waves in that string. So those frequencies are the multiple of the fundamental frequency. So the frequency of the standing waves which are seen are f naught, 2f naught, 3f naught, and so on. And if there are some other frequencies, apart from these frequencies, those frequencies will die out very in a brief time. So these are the frequencies which will be left in the string, and they will be heard for a long amount of time. So these are the frequencies for which we have the standing waves in a string of length L. Now we have first harmonic, then we have the second harmonic, we have the third harmonic, and so on. Okay, and the velocity of the wave V can be written as under root of T by mu. So you can get the fundamental frequency and the other harmonics also. Okay, good. Then we have the standing wave formation when one end is fixed and another end is free. One end is fixed and another end is free. So what will happen at the end which is free? There will be antinode over there, and at the end which is fixed, there will be node. Okay, so the end which is free, that oscillate with the amplitude of 2A. So there is antinode over there. So over here we have antinode and we have node at the point which is fixed. So you can see in between two consecutive nodes, the distance is lambda by 2. But between one node and the consecutive antinode, the separation is lambda by 4, half of this. This is lambda by 4, right? Okay. So over here we have n loops, and then we have half mode loop. So this is lambda by 4 separation. So what is the total length? Total length is n times L plus total length is L. Okay, and we can find out total length in terms of lambda. So we have n loops, n complete loops. So for that each loop we have length lambda by 2. So we have n times lambda by 2, and then we have half of the loop for the length lambda by 4. So we will add lambda by 4 to this. This is the total length L, and we can write the total length L as n plus half lambda by 2. This is the total length L, and you can say lambda, this is equal to V by L, and V by F. Lambda is V by F, velocity of the wave divided by frequency. So you can say L is equals to n plus half times lambda by 2. Now instead of lambda you can write V by F. So we have V by 2F over here because it was lambda by 2. So lambda is V by F. So lambda by 2 is V by 2F. Now from this you can calculate the frequency. The frequency is n plus half times V by 2L. This is the frequency. You can write it as F. Now the frequencies for which we will get resonance or we will get standing waves, those frequencies can be written. So let us put n equal to 0. So we will get f naught equal to v by 2l. And then we can put another value of n. So n can be 1 also, 2 also, 3 also, 4 also, and so on. So we will get the frequencies. So f naught was fundamental frequencies. So f are first is f naught, then we get 3 by 2 times f naught. So we have first of all f naught v by 4l. It is not v by 2l, it is v by 4l. So when we put n equal to 0, we get v by 4l, and then when we put another value of n, let's say 1, we get 3v by 4l. So that is 3f naught. So this is 3f naught, and then we have 5f naught, and then we have 7f naught, and so on. So over here also we get harmonics. We get first harmonic f naught, then we have the third harmonic 3f naught, then we have the fifth harmonic 5f naught, and then we have the seventh harmonic 7f naught, and so on. So we also have a concept of overtone. Okay, so this is the first overtone. Okay, and then this is known as second overtone, and so on. So these are overtones. So first overtone, second overtone, third overtone, and so on and on. Now Biko is there. Indian bike driving 3D is also there. Fine. So okay, good. So I think this portion is clear of standing waves. So we can have standing waves on a string in two cases. One case was when both the ends are fixed, and another case is when one end is fixed, another end is open, and you can have these standing waves. Okay, so I hope you have understood the concept of harmonics and overtones. So over here, what harmonics we have? First harmonic, third harmonic, fifth harmonic, seventh harmonic, and so on. We have first overtone, second overtone, and so on. And you have the frequencies of those overtones. So for first overtone, we have 3f naught, then second overtone, we have 5f naught, and so on. But in the case when both the ends were fixed, we have the first harmonic as f naught, then we had the second harmonic, okay? Then we have the third harmonic, okay? Then fourth, then fifth. And this is the first overtone. Then we have the second overtone. So 3f naught over here is the second overtone. So we must recognize what overtones we have. Okay, good. And now that is okay. And now I will also talk about the equation for standing waves. So over here we have the standing wave, and you can see the equation. Equation is of this form: y is equals to 2a sine of kx cos of omega t. So you can say that at t equal to 0, the equation was y is equals to 2a sine of kx, and we have plotted the graph over here. Okay, and then we have the another term cos of omega t. So that term was 1 when time was 0, and you can see that 2a sine of kx, this is giving us the snapshot at t equal to 0. So we can see the particles at their extreme positions. So we can see the amplitudes of all the particles, and then as the time goes on, the particles will move, and at t is equals to capital T by 4, y is equals to 2a sine of kx cos of omega, which is 2 pi by capital T, times t by 4. So you can see this is cos of pi by 2, which is equal to 0. So y is equals to 0 for all the particles. This is at t by 4, and so on. So with this equation, you can get all the possibilities at different times. Now we have the last question of our session today, and we will conclude after this question. The question says, a massless rod BD is suspended by two identical massless strings AB and CD of equal lengths. So length of AB and length of CD, they are same. Let's take them to be equal to L. So both the lengths are L. A block of mass small m is suspended from point P such that BP is equal to X. So BP is X. If the fundamental frequency of the left wire is twice the fundamental frequency of the right wire, then the values of X is. So what is the value of X? We have to tell what is the value of X. If fundamental frequency of the left wire is twice the fundamental frequency of the right wire. So for the left wire, the fundamental frequency, we will write that F0 1, that fundamental frequency for the left wire, that is equal to V by 2L, or we can say V1 by 2L. And fundamental frequency of the right wire, that is F0 2, that is equal to V2 divided by 2L. So these are the fundamental frequencies of the left and the right wire. And it is said that if the fundamental frequency of the left wire is twice the fundamental frequency of the right wire, then the value of X is. So if F0 1 is twice of F0 2, then what is the value of X? So what is the value of X? This is the question. Now let me give you 30 seconds to solve the question. It is not very difficult. I can give you 1 minute also if you need more time. And you can type the answers in the chat. So the time starts now. तो आप लोगों के पास में थोड़ा सा time है. You can figure out what will happen. So about 1 minute time you have. So Biku is saying I have already solved this question and he knows the answer. Bishu is saying. So okay, so try to solve it one more time without already remembering the answer. Okay, take it as a new question and try to approach it freshly. So you will revise some formulas using that approach. Okay, so I can, if you have already solved, I can give you another question. I can say, instead of massless rod, what if this rod was having mass m? Okay, if this rod also was having mass m and this another block which is hanging is also having mass m, then what would have been the value of X? Okay, you can take that as another question and try to solve that if you have already solved this question. In this question, there is no mass on the I think rod. Let me read the question. The massless rod BD. So this rod was massless. So for the massless rod, if you know the answer, you can make your own question where the rod also have mass m and try to solve that question. And for the others who haven't seen this question earlier, take this rod as massless rod and solve this question. You will get one of the options as the right answer. So anyone? Okay, so 1 minute has passed. So I'll try to help you out, and in case you get the answer, you can comment that in the chat while I'm solving. So the fundamental frequency in the first string is twice of fundamental frequency in the second string. Okay, yes, okay, Rishma is trying. Okay, and so when you get the answer, you can type that in the chat. Okay, so fundamental frequency in case 1 is twice the fundamental frequency in case 2. So we can say that V1 by 2L is equals to V2 by is equals to twice of V2 by 2L. So fundamental frequency is proportional to V. F0 is proportional to V. So if the strings are having the same length, F0 is proportional to V, and we can say that F0 1 is twice of F0 2, so V1 is twice of V2. So this is the relationship between the velocities, and then we know that velocity V is equals to under root of T by mu. V is equals to under root of T by mu. And Sai Kiran also got the answer. And yes, so V1 is twice of V2. So we can say under root of T by mu, this is equal to twice of under root of T1 by mu is equals to twice of under root of T2 by mu. So from this you will get that T1 is equals to 4 times of T2. T1 is 4 times of T2. Now we will go on to the next slide and write this equation. T1 is 4 times of T2. T1 is equals to 4 times of T2. Now this is a fresh question on equilibrium. So now there is no need of waves. The portion of waves which was involved in this question, we already did that, used that, and then we have to apply the rotational mechanics now. So this is the mass which is hanging. So there is mg over here, and there is tension. So tension is also mg. Now the rod is massless. So over here we have the tension T1 and over here we have the tension T2. So this is the equilibrium condition. Now this distance is x and the total length was L. So this second distance would be L minus x. So let us balance out the torque about this point from which the mass is suspended. The torque of mg about this point would be 0 because mg is passing through this point. So this is point P about which we are balancing the torque. So torque of mg at P is 0 because mg is passing through P. But there is torque of T1 and there is torque of T2. So we can say T1 times x. This is equal to L minus x times T2. This is the first equation. Our first equation we already had. This is the second equation. And then we have the third equation that T1 plus T2, this is equal to mg. So we have to solve the three equations to get the answer. Okay. So now T1 plus T2 is equals to mg. T1 is 4T2. So we have from first and third, we have 5T2. This is equal to mg, and T2 is equals to mg divided by 5. Now once you get T2, you can get T1. T1 is equals to 4 times T2, so this is 4 mg by 5, and then you can calculate the value of L. So from the second equation we have T1 times x. So we have 4 mg by 5 times x. This is equal to L minus x times T2. So L minus x times T2. So what is T2? T2 is mg by 5. So you can see mg by 5 cancels out, and we get 4x is equals to L minus x. So 4x is equals to L minus x. X is equals to L by 5. Okay, so it was not necessary to calculate these tensions. Without even calculating the tensions, we could have solved the question only by using 1 and 2. Just you have to put T1 as 4 times of T2. T2 will get cancelled out, so you will get 4x is equals to L minus x, and from that you will get x equal to L by 5. So just using 1 and 2, you could have solved the question. Although if somebody would have asked the tensions, then we should know how to calculate the tensions too. So we have calculated the tensions also. In case anyone is interested, they can calculate the tensions. So this is how we solve the question, and L by 5 is the answer. So option A is the right answer for this question. Option A is the right answer. So Pranjal is asking, will you explain the last part again? Okay Pranjal, I will explain the last part again. So have you understood the three equations, first, second and third? Then I will explain the last part. First, second and third equation, have you understood? Have you understood the first equation? First equation is T1 is equals to 4 times of T2. So this equation we got from the waves. So fundamental frequency was proportional to the velocity. Fundamental frequency in the first string is twice the fundamental frequency in the second string. So this means the velocity in the first string is twice the velocity in the second string. And velocity can be written as under root of t by mu. So under root of t1 by mu is twice of under root of t2 by mu. So this means t1 is equals to 4 times of t2. So this was the first equation which we got. Then what we did, we just said that total upward force on this rod is T1 plus T2. This is equal to total downward force on this rod, which is mg. So we wrote T1 plus T2 is equals to mg. This is the third equation. If there is doubt in the third equation, you can ask again. So T1 plus T2 is equals to mg, right? Is this understood? Clear? If this is clear, you can give some smiley in the chat or some thumbs up so that I get to know this is clear. So this is the third equation. Then we had the first equation, T1 is equals to 4 times of T2. This was the first equation. And we have the second equation also. Second equation is the equation of balancing out torque, because the rod is not having any angular acceleration, so it is in rotational equilibrium. So we can balance out the torque. So we take the point P from which we have suspended the mass. About point P, we will take the net torque to be 0. So the torque due to the first string is T1 times the perpendicular distance, which is x. So T1 times x is the torque due to the first string. This is equal to the torque due to second string, that is T2 times perpendicular distance, which is L minus x. So second string will provide the torque in the anti-clockwise manner, and the first string will provide the torque in the clockwise manner. These two torques will cancel each other out. And the torque due to mg about point P, that is 0, because mg is passing through point P. So perpendicular distance of mg from point P is 0. That's why its torque was 0. So we got the second equation also. So using these three equations, we can get the answer. Now we don't even need the third equation. We can just get the answer from first two equations. So we can just place T1 as 4 times of T2. So from first and second, we get 4 times of T2. This is equal to L minus x times T2. So T2 will get cancelled out, and you get 4 times of T2 times x. This is equal to L minus x times T2. T2 gets cancelled out, so you get 4x is equals to L minus x, and x is equals to L by 5. So only from first and second you can get the answer. From first and second. Is this clear now? I hope this is perfectly okay with all of you. Now we can end our session. So let me just summarize what we have discussed today. We started with the essential formulas in the chapter of waves. And then we also discussed how to write the equation of wave if we have the photo of the wave at any time. Then we also discussed what is the relationship between the particle velocity and the velocity of wave. They are not equal, and they are related with each other, and there is also the slope involved in the formula. So the formula was velocity of the particle is equals to negative of velocity of the wave times dy by dx. That was the formula which we discussed. Then we also discussed the general equation of the wave, the double differentiation equation 1, and then we discussed how to superimpose the waves. We also discussed the standing waves when the waves are traveling in the opposite direction. We discussed the conditions when we have standing waves formed on a string. So we can have two cases when both the ends are fixed, and we can have another case where one end is fixed, another end is free. So we saw what are the harmonics in that, what are the overtones in that, what are the fundamental frequencies, and so on. We also discussed the equation of standing waves too, and finally, we have solved the question on using fundamental frequencies and rotational motion. So this is what we discussed today, and we will look at sound waves in the sessions to come. And stay tuned for that and keep practicing. Have a great festival. Happy Diwali to everyone. At the end of the session, let's dedicate our learning for the benefit of all beings. So bye-bye. Have a nice time. Enjoy. Have fun. And see you all in the next session. Bye.